In an AC current, the total impedance in ohms is given by this formula. 1 over Z1 equals 1 over Z equals 1 over Z1 plus 1 over Z2, where Z represents the total impedance of a circuit that has resistors Z1 and Z2 wired in parallel. So we have 1 over Z equals, and we have Z1, 1 over 3 minus I plus 1 over 2 plus I. And now the problem here is that we really need to put this into standard form. And remember, standard form for complex numbers is A plus BI or A plus BJ. In many of the worksheets, we're using J. Obviously, here we're using I again. We need to change it into A plus BI form. And when we have two terms in the denominator, we can't separate the fractions. So what we have to do is multiply by what we call the complex conjugate. What is the complex conjugate? The conjugate is, if I have A plus BI, and I want to know what the conjugate is, it's A minus BI. Why is that the conjugate? Because when I multiply these together, A squared minus BI squared, which is equal to A squared minus B squared I squared. And again, if you haven't watched the video on complex numbers, I highly recommend it. I squared equals -1. This is really the same as A squared plus B squared. And that's important because notice I've multiplied by the conjugate and gotten something that no longer has any imaginary part to it. Okay, we're going to have to do this quite a few times. I want to change 1 over 3 minus I into standard form. I have to change the denominator, and I have to get rid of the I. Just like when we rationalize, we get rid of the radicals in the denominator. This is where actually, this is called realizing, because we're getting rid of the imaginary part and making the denominator real. I have to multiply the denominator by 3 plus I. But I can't do that unless I multiply also the numerator by 3 plus I. Now I'm just multiplying by 1, so I'm not changing any numbers. This is going to be equal to 3 plus I divided by, and then if we multiply these times each other, again, we have the difference of squares, we have complex conjugates, and this would be 9 minus I squared. And I squared is -1, so it's really plus 1, which gives me 3 plus I over 10. In standard form, this is equal to 3/10 plus 1/10 I. This is in standard form. A is 3/10, B is 1/10. They're both real numbers, which satisfies that criteria. And there we have it. I'm going to come back over here. The complex conjugate of 2 plus I is equal to 2 minus I. So I multiply by 2 minus I over 2 minus I, which gives me 2 minus I divided by 4 plus 1, which is 5. If you don't know how I did that, just follow the steps yourself. It's just the difference of squares, so it's going to be 2 squared minus I squared. I squared is -1, so it's going to be 4 plus 1, which is 5. Let's go back over here. And we'll say plus 2 minus I over 5. And now we need a common denominator. So I'm going to multiply this by 2 over 2. Now my denominator is all 10. I have 10 in the denominator. And I have 3 plus I plus 2 times 2 is 4 minus 2 times I is 2I over 10. I have 1 over Z. So that's important because we're going to have to flip it. So we might as well keep it as one fraction. So again, I have 7 minus I over 10, which means that Z is equal to 10 over 7 minus I. Basically, if you have two fractions that equal each other, you can just flip them upside down, as long as you flip them both. So Z over 1 is equal to 10 over 7 minus I. I need to turn this into something in standard form, and it's not in standard form. So I'm going to multiply by the conjugate, which is 7 plus I. And this is equal to, I'm just going to leave this factored for the moment because I want to see what my denominator comes out to be. But I have 7 squared, which is 49, plus, it's always going to be plus because instead of the difference of squares, it's going to be the sum of squares because we have minus I squared, which is minus 1 or plus 1. So that's 50. So this becomes 10 times 7 plus I over 50. And aren't we glad that we didn't distribute, because then we'd have to factor again. So I can cancel this 10 with this 50 and I get 5 in the denominator. So this becomes 7/5 plus 1/5 I. And now it is in standard form. So we have it in rectangular and now we have to turn it into polar. I have Z equals 7/5 plus 1/5 I. And if I want to find the magnitude of Z, that's equal to the square root of 7/5 squared plus 1/5 squared, which is equal to the square root of 49 over 25 plus 1 over 25, which is equal to the square root of 50 over 25, which is 2. And now we have that theta sub r, remember this is my reference angle, is going to equal the inverse tangent. Always it's positive, but this is already positive, 1/5 over 7/5. I can cancel the 5s, or however you do your math on fractions. But if I multiply the top and bottom by 5, these will cancel, and I'll get the inverse tan of 1/7. This is equal to 8.13 degrees. Since this is in quadrant 1 and my reference angle is in quadrant 1, everything is correct. In polar, I can write this as the square root of 2 at an angle of 8.13 degrees.